presentation is the practical aspects of the YOCTO by Marcin Gudajczyk from Nokia. So, okay.
Okay. Hello, everyone. Thank you for joining to my humble presentation. And maybe we can start with a small of a joke. So, for example, this is my personal favorite wallpaper. This is one of the series from the Poland Ball from the internet you might be familiar with. And this one is Poland Ball into space. But I have made a small change for that. There's the Nokia mark on it. And it refers to one of our managers who once said that whenever you will give the engineers a free hand, they will take you to the stars. So we all feel like that. But sometimes when we put someone into the stars, we start to scratch our heads. Okay, now we have to take them back somehow. Don't get me wrong, I'm just trying to refer to the pressure that we often get during working on some of the projects that we have to focus on really fast delivery. And now let's get back to the presentation. Okay, so today I want to tell you a bit about the YOCTO from a different perspective. Usually, whenever this topic is covered by any presentation, by any workshop, what do we get? We often get presented how to build the image, what the POCI actually is, what's the content of the repository, how the meta layers are created, how you want to modify anything, to change any content of the image you will get produced, how you can introduce any new application, how you can introduce any new meta layer to define your individual content of the project you want to do, you want to create, you want to produce, the image you want to put to the target, to the hardware you are working with, right? So this is the basic stuff. But today I want to take a different perspective from it and focus on some things that we often simply omit. We can skip them because we take them as something very regular. We can sometimes skip it because we don't pay too much attention to them. But I was able to extract some of those things. We usually don't concern about too much. But from my perspective, from my experience, they are very important, and we should be at least aware about them, how to proceed with them, and what are they responsible for. To give you the background, I graduated here in the Wrocław University of Technology, and straight after that I started to work in Nokia in the software configuration management team. So my daily work was related to the maintenance of the production on the component level, on the application level, and also on the production level, when the applications for the product were actually gathered all together and put into the target package. So based on this background, I want to focus on the YOCTO aspects from the integration perspective. This will be the main point, the main key point. Basically, the YOCTO is not only a set of the scripts, right? Because when you produce the distribution, the POCI distribution, you get a lot of the files on that. But the YOCTO is also a bucket of the very good practices, and those practices make it very well designed. And because of this, when you adapt your project to utilize the YOCTO in the backhaul, it actually gets the profit from that. So let us move to the first scenario. Okay? Let's have two of the developers. We'll have the Steve and Dave. So the Steve and Dave one day decided to introduce some kind of library into their project. Hey Steve, I found this very fancy library. We've been thinking about a lot about introducing very similar functionality to our project, And this is something which actually fits into it. Okay, Dave, I think it will be really good to use it in our project. So what do we do with it? I don't know. Let's assume we are developing our application in the native environment. This will be a very simplified scenario. So, we can put it into the sysroot. Let's install it on our production environment, and let's use it straight from there. Okay, but maybe we can just distinguish it just a bit from the regular stuff which is coming from our environment. So let's put it in this place. It's not a standard place, but sure, let's put it right there. Let's build it up, and let's see if it works. After a few minutes of work, Steve and Dave, they conclude that it's fine, it's working fine. That's very good. So we managed to introduce some kind of the dependency, some kind of extra library, and our application is using it, working fine. And the procedure is ongoing with many other stuff. So they put a little bit of here, a little bit of there, and everything works fine, right? But the one day, the boss is coming. Hey guys, you know what? Our application that customer is buying from us is very good. It enjoys it, and we have to move it to the other platform. Really, boss? Do we have to do it? Yes, you do. So how much it will take for you? You know, it's very specific to the platform that we use, because it relies on this and that. What do you mean? Yeah, we have something like that, and it will be hard to port it. So how much it will take you? I don't know, like about 100 hours. What? 100 hours? That's a lot of time. 100 hours per component. Okay. What is it? What? Is it the hard code in the application? So you see. So this is regularly how the situation can end up if you don't put a good attention to the newly introduced stuff into the project. So we have actually two conclusions from this story. The first one will be that we have to use our platform, that we have to define our platform as the minimal set of the items that we put into it, that we put into the sysroot, which includes, of course, the kernel, the modules for the kernel, headers, standard libraries, and so on. So very minimal stuff. This is what should, in my opinion, define the platform itself. Anything else that we want to utilize in our project, in our application, has to be defined as a dependency, and has to be explicitly manifested as the dependency itself. Yes?
I'm sorry to interrupt. There's one important thing. There is a water supply failure in Wrocław, so please do not use coffee machine, because it can be easily broken. Yeah, back to you.
Okay, thanks. So what do we do with that? We have decided that we have to extract it as a dependency, but there are, however, some other procedures to actually do it, because there's a temptation to always, for the platform organizations, for the platforms that we use, so they would obligate themselves, okay, we can actually include such kind of the library of the module into our platform delivery. It's fairly easy to be done. It's easy for the platform because the platform will deliver it within its own package, within its own SDK. The application will not have to take care about maintaining any additional dependency. It seems to be a fair transaction at the beginning. It won't cost much. But again, let's get back to the scenario when the application will have to be cross-platform. And it will have to work and build on top of multiple platforms. So what in that case? It would be fair if the platforms will deliver this dependency in the same version. But usually the platform organizations and the platform projects are really big projects. They tend to introduce new things at their own speed. And the problem will rise when the application will have to deliver the same stuff at the same time to the different platforms, and there will be some kind of dissimilarity between the dependencies versions. And as we all know, this will be a problem. And what to do then? There are a few options. This can be solved at the level of the application with the if-def inside, but we all know this is not good. And the architects of this application can come to the platform and say, what do we do then? We branch our project. This will cost us a lot to maintain. We create a separate repository for that. None of this option looks pretty much decent. So this is a problem, and this has to be avoided. Okay? So this is the first conclusion from the history we spoke about. And there's also the other conclusion: how to avoid such problems with defining and extracting the dependency. The good practice is to define a kind of the interface between the application and the platform. And this is a very typical and regular approach in the open source project. A lot of open source projects actually use this, and there's a lot of build system frameworks which utilize this approach. The interface will have to define the elements of the platform, of the SDK of the platform, and subscribe them with some kind of environment variables. So these variables will have to define the elements of the SDK, like the compilers, like the binutils, and the elements of the platform itself. So it will be the sysroot and any extra element which will be included in the sysroot. Okay? And as mentioned, a lot of build system tooling is supporting this, like AutoTools. AutoTools. With the full respect, the AutoTools, I played with it, with this solution, with this approach. It was achievable, but at a high cost. So even if they support it, it's hard to maintain it. It costs a lot of effort. So I would actually discourage using AutoTools in any approaches, in any new projects that you create, and instead, of course, go to some modern build system frameworks like the Makefile, CMake, etc. Okay, and how we can actually describe how the interface should look like and how the application can utilize it. It can be fairly easy done with this illustration. So on the right side, we can notice the application itself, which contains some kind of source code, and the build system, which is reading the interface. Interface defines some kind of the compilers, linkers, any other binutils, the sysroot, as I mentioned, which is describing the platform itself, which can be, for example, Pokey, right? With this construction, we will have stable elements like the application itself and the interface, which should not change. The platform will be the thing that can be changed. So right now, we can notice that we can pick some other platform which will fulfill the requirements of the application and the interface, which can be the Ubuntu, which can be the CentOS. We can get back to Pokey. You can notice that only the platform changes and the interface and the application are stable. And if this is defined and properly used, our application build system is healthy, and we will be able to easily port it to any platform of our wish. So let us move to the other scenario. And the other scenario will touch a very similar case, However, it will refer to the extra tooling, the tooling which will support our production. Let's get back to the Dave and Steve, and they are figuring out right now how to introduce new version of Python. It was like, I don't know, when the Python 3 was introduced, it was like several years ago. So let's assume that they were using the Python 2, and they decided to move to Python 3, okay? And they started to work on the adaptation of this. They have changed the implementation of the scripting. They have aligned to the new methods, new functions introduced to the Python 3, and everything started to working. Great. So we have the production up and running on the new version of Python. In the meanwhile, Steve and Dave decided to change also the versions, to bump up the versions of some additional stuff, like, I don't know, it might be tar, it might be curl, any other things like that. But then comes the boss. Hey guys, you know what? We have made the release a few years ago, and we have to make some correction to it. I know we don't do the corrections very often, yeah, but you know, we have to really do this. We have to reproduce this old build and apply the changes to fulfill the complaints of our customer. Okay, fine. So we start to work on this. So Dave and Steve get back to work. They are trying to reproduce the old build in the environment they currently have. Hey Steve, I get some strange error. Are you familiar with that? I've never seen this before. Strange. What could actually happen? What could actually cause this issue? You know, you remember we've been changing the Python version a few years ago. Yeah, right, exactly. And if we get back now to the old functions, the old methods we used using this old version, it will start to work. Okay, it works, great. But there are some extra issues with the additional tooling. The tar was using the different flags back then. And in the new one that we actually have in our scripting are not handled by the old version. Okay, so we have to change them again. And after struggles with such approach, they were finally managed to produce the build from the old release, apply the change, and make the delivery once again. You see? So this history brings us to the point at the very important thing that the production environment has to be versioned alongside with the product to guarantee the reproduction possibility of our product in the stable environment, right? If we don't have such a possibility, this will be a threat to our production, because whenever we'll have to get back to the old release and reproduce the build, we have to rely on the stable environment which is used for our application development and the application production, right? And how actually YOCTO supports us with this thing. The YOCTO treats the supporting tooling of the examples that I gave to you, like the Python, tar, and the curl, for example. It actually treats such tools the same as the application. It just builds it from the scratches, you see? So when we have the meta delivered, the meta represents the recipes containing instructions how to build our application, how to build the distribution, and how to build the SDK. So YOCTO distinguishes three types of the SDKs. There's the native SDK, and cross SDK. The one we are speaking about now is the native SDK, the one which is generated alongside with the application. Okay? Just to give you the overview and to contrast this approach with some other that we might be familiar with, that we might met into the production. So what will be the, how this approach is actually making the production easier, how it squashes the elements that we have to take care about and minimize the effort we will have to put into the production and the maintenance of the solution. I want to contrast this approach with another approach which will utilize the virtualized environment. So on the left side, we have the YOCTO approach. The dark blue elements are some kind of the objects. So for example, this is the native host with minimum tooling, and this is by the minimum tooling, I mean the native. The native is a set of the tools which will have to be provided on the host itself. It's just a really minimum, like the compilers, like the Python, because YOCTO is using the Python as well, and that's it, right? We don't want to rely on any other element of the native build host. Instead, we will be able to produce them like the JIT, like the subversion, like any other tooling that will be required for the build process. We'll be able to build it from scratches and generate to the native SDK. So in our approach, we have the native host, we have the YOCTO with our layers, and we generate the native SDK, and then we build our application. We can contrast it with some kind of virtualization approach. Don't get me wrong, I don't want to point any weakness of this solution. I just found it out to be a good contrast for this approach. So in the virtualized solution, when we'll have some kind of the images run on the cloud, on the Docker, on the KVM, on any additional virtualization mechanism, we'll need to have some image which will contain the environment setup, right? And then after we'll have that, we'll also need to have some kind of extra stuff which will define the version of our software and map it on the version of the environment. So this is the warning that comes here, the mapping word. It's like a hate word. Mapping is always bad. And you will have to maintain some kind of mapping to be aware in which image version, in which environment version, the application is guaranteed to be actually built up properly. And this not only comes with the backward compatibility break. Whenever we want to, for example, build our application in some kind of newer tooling, let's take, for example, the compilers, we can also run into a problem of the optimization algorithms, right? So I've heard the stories that the optimization flags were actually able to break the functionality of the software. So this will be an additional aspect of this problem, how the environment can affect the build. So even it would be produced, it will give us a different output, okay? Anyway, when we would need to have the mapping for this, then we'll be able to start some kind of fetching steps defined in the scripts and build our application. There's also one additional aspect that came to my mind just right now. The virtualization solution, the virtualization-based approach for the software building can also make our production depend on the IT structure, right? So even this will be some kind of extra dependency, and it will be hard to skip if we would have to port the production on some other environment. Okay, so with this, we are able now to skip to some kind of next scenario. And in this scenario, I want to bring a story from the Nokia company. I can't though I will speak about this, I can't go too much into the details, just not to compromise any secure data from the company. But anyway, I will try to make the history as generic as possible. So in many of our projects, few of them, some, we use the build framework. It is a very specific build framework. It was designed a few years ago by our colleagues from Germany and Finland. And it was designed based on few assumptions. Let's call it, to not use the corporate name, let's call it the Nokia Build System Framework, NBSF. This sounds just like a US television station name. NBSF. Anyway, the system was based on the Makefile framework. A lot of people were complaining that it was very complex. It was not very well understood. It was hard to understand. But hey, let's take a look on the YOCTO from the other hand. I remember when I first started to get familiar with the documentation, it was like, it's so much of the pages here. Which one do I start with? I felt just like the caveman. I've made that face look. It was like, I don't understand anything. So I started to read something, and it was like, I don't get it. I just start to read the new document. Okay, I don't get anything neither from this side. So I moved to another. Okay, I think I'm starting to getting some point. I catch some sentences. Okay, I read more. And then, okay, I have to get back to the other document I read previously, because there's probably some reference to it. And this is how you start working with the YOCTO. You jump from the documentation from page to page and try to get familiar with the perspective you have with your experience. So based on your experience, you try to map how the YOCTO is actually behaving, what is producing. So this is what I felt when I started to work with the YOCTO. And this was the analogy to the complaints that this Nokia build framework system was actually hard to maintain. There was also one extra reason why people were complaining about it, because it had some kind of extra scripting. And whenever the developer was meant to use this, it was not familiar with the usage practices. Because usually the people from the CM, the people responsible from the production maintenance, knew all the tricks. They knew what to use, which kind of functionality was required in some specific steps, in some specific actions, right? And this is why people were not actually up to this build system framework. Because it was based on the Makefile, it also had to provide some interfaces. So you can realize that the Makefile targets were actually taking the part of the interfaces, and they were defined with a strict naming convention. So whenever anything wanted to refer to an application, it referred through the Makefile target, and the proper stuff was actually built up from the scratches. Anyway, the system had a lot of good stuff with it, and I think it was actually quite well designed, because it was really perfectly optimized. It did not have a lot of unneeded, unrequired stuff in the background to be done. So it was really fast. It allowed to build application with the mixed SDKs. So it was yet another benefit. And what is most important, the whole solution allowed to create independent integration flows for both application on the component level and on the integration level. And this was, in my opinion, very good, very strong point of this framework, because it gave the production a lot of agility and the boost for the production actually. right? But anyway, this is just for the introduction how the build system framework look like. But the key point of this chapter, of this presentation, was that the design of it was based on few assumptions. And one of the assumptions was that the subversion will be the key version control system. And the framework was focused on using the subversion. The creation of this framework defined that the applications within the repositories will have the basic and strict directory folder structure. And this was aiming towards utilization of the subversion externals functionality. Subversion allows to fetch a particular directory from within a repository. With the JIT, for example, you can't do it. I mean, it was possible at the beginning of the Git, but it was, if I recall it correctly, it was prohibited in the newer version of the JITs because it was compromising some kind of the security aspects, and it was disallowed. So anyway, subversion is still allowing to do so. And the fact that the system was designed to utilize the externals functionality and fetch the custom directories made it the version control system dependent. And whenever the company started to realize that a lot of projects are actually migrating to the JIT, the engineers who maintained the system started to think, okay, we now have to adapt this framework to also use the Git version control system. So of course, instead of doing the production, instead of introducing any additional features, they had to put the effort on the alignment of the Nokia build system framework to the utilization of the new version control system. And of course, because the Git was not supporting the custom checkouts, there had to be some kind of overcomes done to properly set up the workspace to build the application from with the same assumptions that were previously taken and defined during the design of the solution, right? And how actually, this is one of the aspects that we usually don't consider while diving into the YOCTO, right? This might be something that is very reasonable at the beginning, at the first glance, that we can check, fetch anything, any sources from the internet, right? And this is the point that I wanted to make, that even though we think it's very native approach, this is very reasonable approach, it's very easy to forget about it, and there's always a window to make a bad decision, okay? And the YOCTO project is allowing us, is actually VCS independent, and it allows us to fetch the data with usage of from the multiple version control system, with usage of the multiple protocols, right? So it doesn't matter what is the revisioning system, what is the storage system of the component we want to get. YOCTO provides so-called fetchers, and this is actually the bitbake functionality, but of course the bitbake is the backhaul of the YOCTO project. So it gives us a set of the fetchers which defines the same API to the download operations, and this gives us the possibility to manage our workspace in an agile way, okay? So we get some more agility in the workspace management. And this is also prohibiting us from making bad decisions and make our solution the VCS bounded, okay? Of course, it also has some drawbacks, and Even though the solution of the Nokia that I described at the beginning was optimized for the workspace consumption, when I compare it right now to the YOCTO approach, the workspace size is getting much bigger here. And this is also the reason behind it is also that the YOCTO is holding the downloaded stuff in some dedicated directories. So whenever it's fetched, it is put right there, and then it is extracted also to the dedicated workspace. So the workspace consumption is like 3, 4, 5 times multiplied with the solution I have described previously we had. And from here, we can get to our final scenario I want to speak about, and this is called, I need this particular version for the build. And this one is directly related to the integration processes. Usually, when we develop the application, we are also obligated to perform some integration steps, right? Let's just skip the aspects of the development process itself and focus on the delivery. So the delivery in the YOCTO project will be related to the introduction of the new recipe into the meta that we have, right? The recipe defines the sources of the component we want to get and build and produce our output. And what YOCTO is offering for that? Usually, YOCTO gets the approach of building everything from the head, which means for me, the integration processes rely on the repository containing one single recipe for a component. This recipe refers to the most recent accepted and tested on the component level version of its software. And this is the default behavior, that whenever we'll take a look at the meta tree, the components will deliver themselves in the form of the recipe, of the single recipe. There are, however, exceptions, and even they are visible not very often, but sometimes we'll be able to notice that the component delivers itself with the few recipes, and the recipes are describing multiple versions. And the default behavior of the YOCTO is that the newer version will be always picked unless decided otherwise. There are few parameters, few variables which are responsible for steering the version picking algorithm, right? And we are able to define which version we want to pick for the build. And because it's possible to define the multiple recipes version, it's also possible to define the dependency to a particular version. So on the one side, we have the solution with the single versions. If we imagine the repository with the YOCTO, with the meta containing the recipes, we can imagine that it will hold a single recipe with a single version. And on the other hand, we have our meta, and within this meta, we have a lot of recipes for one particular component with multiple versions. And they also have the dependencies defined, which are describing the particular version of some other component which has to be built up in front of the target one, okay? And this leads us to the two integration approaches, okay? On the left side, we have the one which is defining the single recipe version, and it actually aims for centrally controlled integration. So I would advise this solution for the projects which are really tight, which are able to run the tests on the integration level very quickly, and which are not going to maintain for a long time, right? On the other hand, here we have the multiple versions, multiple recipe versions integration approach, and this approach, in my personal opinion, it really enhances and encourages the components to push into the local level integration approaches. So this approach, in my opinion, is much better for the big projects. For the big projects, and especially the projects which have on the integration level exhaustive and time-taking hardware tests. So first of all, we will need to test everything on the component level, and then with the description of the version dependencies of the one that we are particularly interested in, put them into the meta layer and then propagate through the tree dependency up to the integration level, and then build it on the integration level in the coherent environment with the proper versions matching for all the components, so that the dependencies versions would be always fulfilled on the integration level. The approach with the single recipe does not require the versions dependencies to be defined, right? We usually have only one recipe in the repository, so we always use this one particular version. And as I mentioned, on the solution with multiple versions recipe, it's actually advised to define the versions in the dependencies, right? The first solution, the first approach, allows the component sources because, of course, we want to have the possibility to also define which of the element of the build we want to substitute, either manually or in some kind of the automatic way. So in the first solution, we do it just by substituting the content of the recipe. And in the second solution, we are allowed to actually pick the versions, because we have multiple recipes available, multiple versions of the same recipe available. We can define which version we want to pick. The bitbake, however, will analyze the data defined in the dependencies, and if we have the versions also defined in the dependency, the bitbake will notify us if this version is somehow not the same as within some kind of other application dependency. So we have extra bitbake guarding on the guard and informing us if we decide to build our application with some kind of too old dependency or not. Okay? So these are the two approaches we can achieve with the decision. Either we go with the single and the only one version on our integration layer, or multiple versions of the recipe on the integration layer. And that would be actually quite all that I wanted to present to you today. Do you have any other questions? Okay, so I guess that's it. Thank you for the attention.